Okay, this video is for AP Calculus, and this is the last video in this unit. We're going to talk about average value of a function versus average rate of change of a function, and how we only use an integral for one of those two. The phrasing is very specific. AP Calculus on both the AP Calc AB and AP Calc BC exam, this is definitely going to be important to know this difference because they have problems of both types on those exams. So for the average value of a function, that's just averaging something. So to introduce this idea, let's just talk about numbers. If you wanted to find an average of a set of numbers, like let's say you wanted to find the average of 2, 4, 6, 8, and 10, you would just add the numbers up and divide by the number of numbers. So this would be 2 plus 4 plus 6 plus 8 plus 10 divided by 5 is an average of 6. So the average value represents a typical value of that same set. So it doesn't change the units in any way. If these numbers are, let's say, um, scores on some medical test or something, then this is the average score on a medical test. Okay. So if you have a function that's defined over an interval, then that means the average value of the function also has to represent the typical y value of that function over that interval. Right? So we have to do something equivalent to adding up the y values and dividing by the number of y values. Right? So this adding up the y values part here is done with an integral. We just take an integral from a to b of the y values of that function. And then to divide by the number of elements, well, technically you added up, you included a number for each of the x's in the interval, so you simply divide by the width of the interval, b minus a, and that is defined as the average value of the function on the interval from a to b. Right, so usually it's written this way. They take this integral and move it down, and they say it's 1 over the width, b minus a, times the integral from a to b of the function. So this is adding up the y's, and this dividing by the number of y's to give the average y. And the units are whatever the y values units are, y value unit. Okay? You can think of it this way, right? If you were just to take this area here, this integral, that represents the actual area under the function curve, right? But the other way to get that is if you take the average y value, and if you take this formula and you multiply both sides by this b minus a, you would get b minus a times the average value equals the integral from a to b of f of x. So the other way to think of this is there is some y value between the minimum y and the maximum y, where if you took that height as the height for the entire width, that area would be the same as the actual area. So that's the kind of intuitive understanding for what the average value is. It's the average value, the average y, but if you took that y for all of the x's and just multiplied by the width, you would get an area that's equivalent to the actual definite interval area. Okay, so here's an example. The number of people who enrolled in an adult education class over the 40-day enrollment period is given by this function, where t is in days and f is the number of people. Find the average number of people enrolled over the enrollment period. Average number of people, so that's an average value. All right, so we're going to say this. It's going to be the average value is equal to an integral. Well, in general, let me just develop this. It's 1 over b minus a times the integral from a to b of the function. So in this case, the average number of people is 1 over 40 minus 0 times the integral from 0 to 40 of that function. 1 over 40 times t squared plus 1/2 t, and then we're integrating over t. So if you were to plug that into Math 9, that turns out to be 23.333. And the units here, since this is an average y, would be the y units, which is people. You should not round this to the nearest person. You should leave that accurate to 3 decimal places. Right? An average is a computed number, so it does not have to be an actual value that's in the set, which are possible. So you should leave that unrounded. Great, and that's it. That's all there is to average value. Just use an integral to sum up, find the average divided by the width of the interval. Okay, now this is really important. The average value of a function is different from the average rate of change of a function. If we had the same setup, but we asked for the average rate of change in the number of people, well, the average rate of change is a rate. And that means it's like an average derivative. So it is literally change in y over change in x. It's like a secant line slope. It's the average rate of change. It's the change in y over the change in x, which represents the slope, the average rate of change. So to compute that, I would say average, well, you could write it out, average rate of change. Sometimes teachers will abbreviate this AROC, average rate of change, is equal to, I would write this. It's the function value at the end of the interval minus the function value at the beginning of the interval over the width of the interval. So we're not summing up all the values, we're just finding the values at the ends. So this would be, let's see, if you plug in 40 into this function, you get the number 60. And if you plug 0 into this function, you get 0 over 40 minus 0. So that is 6/4 or 3/2 or 1.5. Now the units here, since it's a rate of change, are slope units. So that's going to be people per day. Right, that's really important. And usually in a question like this, if it's a free response question, like half of the credit will be in the units to make sure that you understand the conceptual difference between average rate of change and average value. Okay, let's look at a couple more examples just to illustrate that. So just keep these two things separate. When it says average or average value, they mean for you to use the integral. That's the average y value. When it uses the word rate, average rate of change, then it has to be a slope form. And that means you're taking literally a change in y over a change in x. Okay, here's a function, same interval, find the average value, find the average rate of change. Go ahead and pause the video, see if you can get both these correct, and then unpause and see if you got them right. Okay, so our average value, the expression for that is going to be 1 over 4 minus 1, but times the integral from 1 to 4 of x cubed minus 3x squared. And that one turns out to be 0.25. It'd be nice if I included units. This would be whatever the y unit is. Average rate of change, that's going to be f at 4, so plug 4 in, minus f at 1 over 4 minus 1. So they both have a divide by 4 minus 1. It's what's happening on the top. And this one would be 16 minus negative 2 over 4 minus 1. And that turns out to be 6. So we should have gotten 6. And the units there would be something per something, because that would be a slope unit. Okay, let's do one that does have some units. And this is the last example. Okay, an object's temperature in degrees C is changing over time and is given by this function. Capital T represents the temperature and lowercase t represents the time. That's in degrees C. Time is in hours, and this is defined and usable from 0 to 20 hours. What is the average temperature of the object over that time interval? Okay, so for part A, we're going to say, I like to write this, T average, the average temperature is going to be, that is an average value, right? So that's going to be 1 over 20 minus 0, integral from 0 to 20 of this t function. I don't need to copy it again because it's in the problem. If you plug this in your calculator with Math 9, you should get 38.289, and the units there would be the y variable unit, which is just degrees C. Right? For part B, that's an average rate of change. So the average rate of change is equal to the temperature at 20 minus the temperature at 0 divided by the time interval. So that, if you plug 20 into that function, you would get 65.843853, etc., minus 26 if you plug a 0 in there. And then you get divided by 20 minus 0. That turns out to be 1.992. And the units there would be degrees Celsius per hour. So degrees C per hour, or you can write it out, degrees C per hour. All right, so if you got both those right, you got the key idea. The main thing we want to put these in is this is the last of the kind of basic uses of integrals and the difference between average value and average rate of change.